Hi all, and welcome to the Emergent Vision Technologies presentation. I am John Eilert, President, CTO, and company founder, and I look to provide details of how Emergent has become the premier supplier of cameras supporting any speed, any resolution, any cable length, any sensor, and any application. Some highlights about Emergent are presented here. We are a multi-award winning company with a focus on high-performance GIGI Vision product. We have many years shipping product at speeds of 10 GiGi, 25 GiGi, and 100 GiGi. We have a strong focus on providing end-to-end technologies and comprehensive support for our customers' applications. As we will see in this presentation and another presentation later today, performance applications are more than just fast cameras at high speed, but are also about many lower speed cameras in single server applications. Here's a quick snapshot of the adoption of GIGI Vision products ranging in speeds from 10 GiGi up to 100 GiGi. Emergent has shown how top performance can be achieved and opened up many markets, including machine vision and entertainment, to the use of such technologies. Some companies are just now leveraging our efforts towards releasing 25 GiGi and higher speed product, but still a ways to go to provide ratified, mature, and performance product. Speeds like 10 GiGi, 25 GiGi, and 100 GiGi are a must-have in many applications. However, as we launch our new Eros 5 GiGi line of cameras in 2024, we will be leveraging our deep experience in performance applications to reliably support 5 GiGi and lower speeds in one or many camera per server applications with a wide variety of performance processing options in the same zero copy, zero loss sense. With such a broad range of products, we find it helpful to chart out the various resolutions and frame rates provided. At 10 GiGi, the products range from 0.5 megapixel at 1500 frames per second, up to 50 megapixel at 23 frames per second. At 25 GiGi, the products range from 0.5 megapixel at 1600 frames per second, up to 127 megapixel at 17 frames per second. And at 100 GiGi, the products range from 2 megapixel at 3462 frames per second up to 152 megapixels at 16 frames per second. For line scan, the products range from 4K at 172 kilohertz line rate up to 16K at 400 kilohertz line rate with a special nod to 9K TDI at 600 kilohertz line rate. As we launch our new Eros 5 GiGi line of cameras in 2024, we will introduce many of the same sensors we already support, but now in lower speed, lower cost, and much smaller size options. While SWIR is coming to 10 GiGi soon, we will also include SWIR in the Eros product line. As one can see, the sensors Emergent supports vary greatly in size, pixel count, pixel size, and data rate. We include a wide variety of both area scan and line scan sensors from the premier suppliers Sony and G-Pixel. Emergent area scan cameras are best known for covering an extremely wide range of resolutions and frame rates. We incorporate all the best sensors from Sony and G-Pixel. Sony boasts very high image quality with resolutions and frame rates a perfect match for the Emergent 25 GiGi Bold series and 10 GiGi HR series. G-Pixel boasts high image quality with resolutions and frame rates that push Emergent 100 GiGi Zenith series to its limit. Eros 5 GiGi cameras will join the lineup in 2024 to further expand into lower speed but still higher performance multi-camera applications. Emergent line scan cameras are best known for covering an extremely wide range of resolutions and line rates. We incorporate all the best sensors from G-Pixel. G-Pixel boasts high image quality with resolutions and line rates that push Emergent 100 GiGi Pinnacle series to its limit. Emergent 25 GiGi XL and 10 GiGi Pace models nicely round out the line scan product portfolio. Eros 5 GiGi cameras will join the lineup in 2024 with smaller resolution models like 2K and 4K. RJ45 is familiar to most and is there to support up to 10 GiGi speeds but not beyond. This uses Cat6a cabling typically and supports up to 100 meters. PoE is an option here but adds approximately 1 watt of power, which either creates a block heater out of small cameras or requires a larger camera enclosure to dissipate the heat. We note that these options also include a PHY chip in the camera, which can consume 2 to 3 watts, which also add to the heat dissipation requirements of the camera. SFP Plus and SFP28 share the same form factor and are used for 10 GE and 25 GE speeds respectively. Noting again that these standards do not support PoE, cable options include direct attach, multi-mode fiber, and single mode fiber. Direct attach cable is a single piece passive cable designed to drive shorter lengths of cable. AOC, or active optical cable, is also a single piece cable but has transceivers and fiber integrated into a fixed length cable. Typically, this is a multi-mode fiber cable used in medium length cable runs. Single mode fiber and multi-mode fiber are also constructed in 3-piece configurations made up of 1 fiber and 2 transceivers, 1 at each end of the fiber. The fiber connects into the transceivers most commonly with an LC to LC fiber connector. QSFP28 is used for 100 GE speeds. Noting again that this standard does not support PoE. The cable options are the same as for SFP Plus and SFP28 options. Most are familiar with typical visible sensor technology and their applications, which indeed easily form the majority of camera deployments. Visible sensors have sensitivity in wavelengths between 400 nanometers and 1000 nanometers. Sony's new IMX487 8-megapixel UV sensor, capable of 200 frames per second, has UV sensitivity in wavelengths down to 200 nanometers. The ever-expanding scope of UV applications includes using the scattering nature of UV light for detecting fine scratches on semiconductors, using the high optical resolution of UV light for detecting smaller features on semiconductors, using UV transmittance variance by materials for more diverse range of inspections, using the differences in UV absorption rate among organisms for expanding types of observations, using the UV emission characteristics for UV luminescence applications, such as power grid degradation inspection. Sony's IMX990, IMX991, IMX992, and IMX993 SWIR sensors range from 1.3 megapixel up to 5.3 megapixel at 260 to 130 frames per second respectively. SWIR sensors have sensitivity in wavelengths up to 1800 nanometers. The ever-expanding scope of SWIR applications includes: at 1450 nanometers, water absorbs light at this wavelength, which allows water detection in objects. Different materials absorb and reflect light at different wavelengths to aid in material analysis. SWIR penetrates certain materials, which is useful in semiconductor inspection, for example. SWIR can observe heat over 250 degrees Celsius for temperature analysis. Sony's IMX253 12 megapixel and IMX250 5 megapixel polarized sensors are capable of 80 frames per second and 163 frames per second respectively. Polarized sensors have sensitivity in wavelengths between 400 nanometers and 1000 nanometers. The ever-expanding scope of polarized applications includes reflection removal in ITS applications, direction of polarization and degree of polarization for surface inspection applications looking for scratches, dust, stress, and strain. See our presentation later today for a demo of our real-time polarization plugin within our eCapture Pro software. The common factor in many applications Emergent supports is performance. The most demanding applications are in VR, where we have deployed a 500 camera setup with 40 times 25 GE cameras per server. These same benchmarks are used to deploy systems in transport inspection, food inspection, and biomechanics applications, for example. The other factor not to be outdone is in the quality of the images and cameras as a whole, which is critical in pharma and AOI applications, where FDA and 24/7 operation is required. We will now review some of the technology behind performance systems we support. Performance systems can be comprised of many 25 GE cameras talking to a few servers with multiplexing and PTP features utilized by low-cost switches. Performance systems can also be comprised of lower numbers of 100 GiG cameras talking to a few servers, with the same multiplexing and PTP features utilized by low-cost switches. Performance systems can also be comprised of a large number of 5 GiG or even 1 GiG cameras talking to a single server with multiplexing and PTP features utilized by even lower cost switches. We find that this is a pain point for manufacturers of lower speed cameras, and so we leverage our expertise in high performance systems to provide best-in-class system density alongside of low system cost with the introduction of the Emergent Aeros 5 GiG line of cameras. In addition to powerful processing engine NICs like the AMD Xilinx Alveo cards and Emergent's own FPGA-based NICs for additional functionality beyond standard NICs, we pioneered the use of Mellanox NICs for use with performance camera systems. We now have support for equivalent Broadcom NICs for addressing cost-sensitive markets. 100 GiG, 25 GiG, 10 GiG are all supported, noting that 5 GiG and lower are also supported to provide the same performance benefits for medium to high camera count systems through the use of low-cost switches. With high-performance processing options available in GPUs and FPGA cards, one can create the lowest cost and highest density system in the industry. See our presentation later today for a demo of the real-time GPU plugin feature within our eCapture Pro software, all of which utilize GPU Direct for maximum performance. We will now take a deeper dive to understand what one should look for in a performance GiG Vision implementation. This short animation illustrates the process of splitting GiG Vision network packets into images. Headers, leaders, and trailers get consumed by a control process, while the image portions end up in a contiguous memory buffer. When software is used for this process, the whole packet is written to memory, and then the image portions need to be read out of memory and written back into another memory location in a non-fragmented or contiguous manner. This process can be done in software which costs 3 times the memory bandwidth, or it can be done by the card's header splitting features for optimal performance. Conventional GiG Vision and TCP are both examples of low performance processes. And don't be fooled by guaranteed transfer mechanism claims of some TCP implementers, which is simply meant to say that if you receive a frame, that this frame will be complete without any corruption. This is not a guarantee that you will not drop frames. In all senses, TCP is a non-starter for performance application and amounts to little more than marketing noise. This short animation illustrates the triple memory bandwidth usage of a system that does not utilize a zero copy or header splitting technology. A system like this can result in data loss as memory bandwidth is exhausted. Data loss occurs when the buffer in the network card overflows, when the CPU and memory do not permit further transfers. This, incidentally, is what RDMA proponents compare with when discussing pros and cons of traditional GiG Vision and RDMA, which is very misleading as this is the worst case example. This short animation illustrates the zero copy memory bandwidth usage of an optimized GVSP-based system using zero copy. We see in this animation that data flows freely and reliably thanks to zero copy and system optimization. The same approach is also used for the ST2110 or SMPTE2110 streaming protocol for the massive media and entertainment market, where zero loss is also critical. RDMA and Rocky V2 also supports zero copy transfer, which is its primary benefit. Some will continue that this is now the guaranteed transfer mechanism, which is again false. At high speed, proper system design and margining is important to create a zero loss system for any protocol, but we note that zero copy is the critical first step. This short animation illustrates the zero transfer process using GPU Direct, which completely bypasses the memory and utilizes only the PCI Express endpoints of the CPU for zero memory bandwidth and zero CPU utilization. This short animation illustrates the FPGA card process, which completely bypasses the memory and CPU for a zero memory bandwidth and zero CPU utilization, since all processing is completely done on the FPGA card. This slide highlights the point about multicast technologies. GiG Vision plus GVSP is currently the only protocol which supports this fundamental networking feature. Other standards will be quickly dismissed in applications requiring efficient redundancy and distributed processing. This short animation illustrates how the data from one camera can be sent to multiple devices for parallel processing. A simple use case could even be where a separate system is used for display while one system performs intense calculations. This slide is an illustration of how the proposed or ratified changes are converging the interface standards. USB remains mostly the same but is a point-to-point technology. CXP has adopted the Ethernet physical layer, converging towards GigiVision. GigiVision plus RDMA and GigiVision plus TCP, if and when ratified, is converging to CXP and USB as a point-to-point technology. This is perhaps 2 years out. GigiVision plus GVSP will maintain its integrity and feature set and not converge with other protocols. With the introduction of the use of TCP and RDMA for GigiVision image transmission, we see that for some camera providers, the use of these different protocols is creating a fragmented landscape whereby different NICs and drivers will need to be supported across the industry by various third parties. With top performance, Emergent is able to maintain the current protocol across all speeds of interface and not jump around with different protocols and NICs to support your needs. Why are packet resends used with TCP and RoCE v2, and what are the implications on jitter and latency? If a system is not well designed and tuned, then no amount of resends will allow the system to run in a stable manner, and will indeed drop packets and frames. In addition, when image transfer bandwidth is slowed due to poor system design, then buffers fill up. The fullness of the buffer is a measure of the system latency. The filling up and draining of this buffer is a measure of the system jitter. Both jitter and latency are important in machine vision systems, especially in those needing to make timely decisions, and both are a sign of an unstable system with poor or no safety margin. What we see is that RoCE v2 requires more FPGA resources to implement, and as such the cost of the FPGA will be higher than that of the lightweight, standard, and mature GigiVision GVSP protocol. This is even more so true if a resend buffer is implemented. We see that in order to create the smallest and lowest cost camera, that these cameras from various manufacturers are not supporting RoCE v2 below 10 GiG. This is one way in which Emergent's new Eros 5 GiG offering will continue to provide true zero-copy performance, while the others rely on TCP and conventional GVSP processing, which yields 3 times memory bandwidth and 33% efficiency of the Emergent zero-copy methods. In multi-camera systems, Emergent will remain unmatched in system density and price performance metrics. And remember that while many state low CPU utilization, that it is actually memory bandwidth utilization that is hiding in the background and preventing maximal system performance. I will leave this summary as a little added reading which captures the current landscape of RDMA and RoCE v2 and GVSP performance implementations with Emergent. I wanted to provide a few examples where customers have come to us reporting a poor experience with another vendor's high-performance camera product. In one such recent example, we have 20 times 5 GiG cameras on a single PC. 2 major camera manufacturers could not resolve drop frame issues. In another example, we have 5 GiG cameras on a single PC. Over a 2-year period, the vendor made many attempts to resolve drop frame issues but never could. All of these customers are now happily using Emergent product. There are 2 very disturbing problems here. One is the poor performance some vendors are offering for their high-speed camera product. The other is that a vendor would actually sell multiples of cameras without having a discussion about what the customer's goals are to ensure the product and system can meet their needs. Our cameras are everywhere you care to look. We dominate in certain spaces where adoption rate is more rapid. We believe other spaces will follow, especially where factors such as performance, cost sensitivity, system simplicity, and time to market are at play. As you can see, Emergent has the highest performance camera portfolio, and we keep your overall product portfolio focused. We innovate, develop, adapt, and expand the markets we enter and have the foresight to do so. Please do contact us for further details, and we appreciate you taking the time to view our presentation.